Alright, we're going to be working on Descartes' rule of signs. So this theorem, our rule, is just to find how many positive, negative, and imaginary solutions any polynomial could have. So to get started on this, we have to look at let's look at the positive changes first. And that's how many changes in signs the original equation is. So let's look at the changes. And what do we mean by that is the negative and the positive is how much they change. So this is treated as a positive. That's one change. And then this doesn't change. Negative to positive, that's a second change. And then positive, 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 negative, third change. And then negative to positive, fourth. So there's four positive solutions here. And then to find this negatives, wait, let me just write this up. 3, and 2. Here we go. Here are the negatives. So to find the negative, the total number of negative solutions, you got to plug in negative because this is f of x. However, you have to plug in negative x instead to find the negative solutions. So negative x, so you see all of these, you put negative x. And the thing about these is that the rule is now that if the exponent is an even number, it stays the same, like over here. And that's because imagine this was -1. -1 to the 6th is just 1. So it doesn't change the equation at all. However, for odd exponents, like -1 to the 5th would just be -1. And then -1 times -3, that would make it a +3. So the odd exponents are the ones that ultimately flip the sign. So instead of -3x, it's going to be +3x. So now let's do it. So we know this doesn't change it. So it's still just 2x to the 6th. It's odd, so now it changes to +3x to the 5th. And then this is even, so it just stays the same, -5x to the 4th. This, it's an odd, so it's -9x cubed. Even, so it stays the same, 7x squared plus 7x squared. It's an odd, basically, so it's going to become +4x. And then plus 8, there's no variable. And now we just count the changes in this. So now we got a positive in the beginning. So positive, positive, no change. Positive, negative, that's one change. Negative, negative, no change. Negative, positive, that's a second change. Then it goes positive, 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 positive. So there's only 2. So now there's 2 negative solutions. And also, we have to look for imaginary solutions. However, look at the highest degree. This is the highest degree is 6. So that means the total possible number and the highest amount of solutions that this equation can have is 6. So since 4 and 2, there's 4 positive solutions, 2 negative solutions. So those already make up our 6 solutions. So that means, therefore, there cannot be any imaginary solutions in this scenario. However, this is not it. There can also be 2 other cases. Because you can, from 4 positive solutions, the negative solutions stay the same for each case. Alright? However, with positives, you can go down, subtract 2. So then you can do that, and then you can subtract 2 to make it 2. So there could also be 2 positive solutions right here. Hold up, let me just... And then the negative solutions always stay the same. So here's 2. And then now, instead of 6, they add up to 4. So that means there has to be 2 positive solutions, imaginary solutions, so that it matches with that highest degree of 6. So this could also be a case. However, there could be also one other case, because you can also do 2 minus 2 equals 0, as long as it doesn't go to a negative. So our third case could be that there could be 0 positives, and since the negatives stay the same, remember, the negative is still 2. And since those add up to 2, now the amount of imaginary solutions in this would be 4. So these are the 3 cases that Descartes' rule says. There could either be 4 positive solutions, 2 negative solutions, 2 negative, 2 positive, 2 imaginary, or 0 positive, 2 negative, and 4 imaginaries. And that's all using Descartes' rule. Let's go through another example. Alright, so here's our next example. So let's get started. Now you know all this content. It should be pretty easy. So positive solutions, let's look at the changes. One change, not change. There's another change, negative to positive, positive to negative. That's 3 changes. All right. So we got 3, let's write this somewhere else, more space. So we got 3 positive solutions. And now we look at the negative. Let me just Alright, so I wrote it out. I plugged in negative x instead of x in here. And let's see. So remember what I said. Let's write down negative here. And so remember what I said about how the evens don't change it. It stays the same like up here. But the odds do change it. So that means this will just be x to the 4th. And then this will change, making it, instead of negative 3x cubed, it would be positive 3x cubed. This would make it still the same, negative 10x squared. And then this would make it different, negative 8x, because of that 1, and then 1 is odd. And then negative 16. So now we just look at the changes here. Basically positive, no change, 1 change, and it stays at negative. So now 3 positive, 1 negative. So we see here the highest degree is 4. So there could be 4 possible total. I mean, there's just 4 total solutions. So with our imaginaries, since there's a total of 4, these two already add up to 4. So imaginary is just 0. However, of course, there's another scenario. You could do 3, 3 minus 2, you can get 1. So there could also be another scenario where there's 1 positive solution, negative of course stays the same as 1. And then here, since it's the total is 3, the imaginary would have to be, there would have to be 1 imaginary solution in the second case. And yeah, here your number of positive, negative imaginaries. Let's go through a third example. All right, so here's the last example. Let's go through it. So let's look at the positive number of positive solutions now. And let's keep in mind that our total number of solutions is 3 because of the highest degree. So let's write out our negative and imaginary, the columns. So no change, no change, and 1 change. So over here in this case, there's only 1 change. So that means, let's look at negative. Negative x cubed times 4 plus 3 negative x squared plus negative x minus 10. All right, from here, now we just look at here, and remember the odds make it so it changes. So now it's negative 4x cubed. Even makes it the same, so keeps it the same. 3x squared minus x minus 10. See? And now we look at the changes. Negative to positive, that's 1. Positive, negative, that's 2. Negative, negative. So we got 2. 2 negatives, and since those add up to 3 already, there's no imaginary. And now look, can we go down from 2 from the positives? So we have 1 positive solution. Can we go down 2? No, that would give us negative 1. So that does not work. So that means this is our only case. It's not like 2 or 3 where 3 minus 2 equals 1 or 2 minus 2 equals 0. If it's a negative, there are no other cases. So this is it. 1 positive solution and 2 negative solutions for this. And that's how Descartes' rule of science.